Hi, so it's December 1st, and this is going to be our review session for the course. There are two sorts of things that I want to cover. One is at least one student was kind enough to send in some questions, and I'll try to answer those. And then I also prepared here a sort of sample final exam, and I'll go through what it looks like and what some of my expectations might be of a model answer. Okay, so the first question relates to hazard distributions and kind of what they mean. And so the question is, you've got a normal distribution and it represents the height of 30-year-old males. What does the hazard information tell us, the hazard function? And the answer is not very much. A hazard function is really used primarily when you're looking at longevity analysis, be that some kind of mechanical part where you're looking at the risk that a part will fail, or a human life where you're looking at the risk that a human life will transition from the living state to the dead state. And so although you can compute it, it doesn't have an obvious meaning outside of time-based contexts. Does that make sense? I'm a little confused on when to use simple linear regression and when machine learning algorithms are appropriate. If the data looks linear, then try regression, and if it's mixed around a multivariable, then use machine learning. So I wouldn't say that this proposed answer here is exactly right. So I don't think whether you should be using linear regression or something fancier, such as a machine learning algorithm, depends so much on the nature of the data, but what you're trying to do with it. If you are trying to prove to someone that some factor is statistically significant, that is, some perceived relationship in the data is unlikely to have been caused by random forces, then you want to use a statistical method, and either linear regression or the sort of somewhat linear methods like logistic regression or probit regression, or you could even use some nonlinear regression. But you're going to use a regression-based system, or you're going to use classical statistics such as a chi-square test or a Fisher test or something like that. So as it happens, and where it gets confusing is, as it happens, these regression-based methods are also good at predicting. They're also kind of a very simple form of what I would call machine learning, and in machine learning, the object is not so much to prove that something couldn't be the result of chance, but to come up with the best method of prediction you can and identify how vulnerable it is to getting the answer wrong. Okay? So I think it depends more on what your goal is, and you might have both goals, in which case you might want to use both techniques, and I think I'll illustrate that in the sample exam that we go through. And machine learning's virtue, in some sense, is it generally, remember the idea is you're trying to generate sort of this universal function generator that can model any relationship, but the hazard of doing that is that you'll do too good a job and it won't hold up. Okay? The disadvantage of things like linear models or logistic regression is you're sort of forcing it to assume that it's linear, and only the little basis functions that you mentioned, and usually those basis functions are just the variable names. Sometimes we get fancy and we'll say it's the product of two variables or a variable squared. But you don't really know that that's the relationship. And so the virtue of statistics is you sort of can prove things, but the deficiency is that it's not good at finding things out. If you have some reason based on the physics of the situation to think that the model is linear, then linear regression makes a lot of sense. But if you don't think it's linear, then linear regressions as a machine learning technique is not particularly good. Okay? So, when is GLM used versus LM? Okay, so LM rm is going to be used where you have reason to think that the error, if you used a line, was normally distributed. That is, the error is basically distributed normally around the predicted value. And there are lots of things that are more or less fall into that category, or even if they don't, it's not such a bad